Okay, let's look at other special pricing strategies. We can have peak load pricing, two-part pricing, price skimming, which means charge a high price if the products first appear in the market, for example, like Xbox 360. We can have penetration pricing, using low price to get the market share. We can have prestigious pricing, which is to charge a high price to make the product look like prestigious. Okay, we can have psychological pricing, charge a price of $6.99 rather than $7. And in the supermarkets, we actually see quite a few such kind of psychological pricing. Let's look at peak loading pricing in more details. Imagine that there's a physical limit in the amount of product which a particular firm can supply at any given point in time. So which means the supply curve looks like this. So initially this one, or maybe initially horizontal, let's say, up the marginal cost. Then when reach the limit, this is called Q upper bar, it becomes vertical. So a classical example here is a limit to the number of phone calls which can be made with limited number of phone lines. In addition, there might be times when the demand for the product is so high that you cannot satisfy everyone's need, which is peak time. And there are also times that we have excess capacities. Okay, if we are faced with such a situation, what is an optimal pricing strategy? The idea here is actually simple. Well, let's charge different prices in different situations. In peak times, we charge a price. In non-peak time, off-peak times, we charge another price. And in terms of determining particular the price label, we follow MR equal to MC. It's like this. So marginal cost, that's a supply curve. Before the limit is horizontal, is constant. Then when the firm hits the limit Qmax, then it becomes verticals. Okay. In the peak times, so the demand is high. In the off-peak time, the demand is low. Okay, what we want to do is, okay, this for the peak times, from the demand curve, we work out the margin revenue, which is twice steeper than the demand curve. Okay, and using MR equal MC, so now this is MR, this is MC, so intersection points this, which means producing a quantity at the maximum. Get the price. To set the price, go from quantity up to the demand curve, read out the price. That's peak time price. When it is off peak times, then the demand is low. Again, similarly, work out the marginal revenue, follow MI equal to MC at this point, which means produce this many units of output, go from quantity up to the demand curve, read out the price. So that's the price for off-peak times. So this is what we call peak load pricing. Sometimes we can have two-part pricing. Okay. Usually we are going to have, say, demand like this, associate MR, and that's the MC is a constant marginal cost. MR equal to MC produced at this point. That means a quantity of 6 units. Go from quantity up to the demand curve, read out price. So it's 10. Marginal cost is 5. So profit is this area. So it's 30. But let's do a two-part pricing. I'm going to say, okay, in order to purchase my product, I'm going to have a membership. You need to become a member in order to qualify to purchase my product. And the membership fee is, I'm going to set the membership fee to be this triangle, which is the length of this side, 15 minus 5, so it's 10 times 12. So this triangle is 1/2 times 10 times 12, so it's 60. So you need to pay a $60 membership fee. Then after that, you are able to purchase my product at the flat rate of $5 each unit. Okay. So in such cases, the firms can actually achieve even higher profit than the MR equal to MC case. Okay, frequently, firms produce multiple products that may be related either on the demand side or on the production side, the cost side. In such cases, how can we use alternate pricing strategy? Okay, let's look at goods and services related on the demand side. Goods can be complements in terms of demand. For example, okay, that means an increase in the quantity sold of one good will bring about an increase in the quantity sold of the other. An example would be a fast food restaurant sells both hamburgers and soft drinks. Sometimes products can be substituted to each other, which means that an increase in the quantity of one product will result in a decrease in the quantities sold of the other. For example, like different models of cars produced by the same company. Okay, let's look at complements and demand. So in such cases, the idea is okay. Let's look at this little example. Suppose a shop sells both computer and software, and computer and software, they are complement to each other. All right. Let's initially let's do not bundle these two products together and see how much how much revenue we can receive. Okay, and followers assume that I'm the shop owners. I want to sell both computer and software to both consumers. All right. Okay. So in order to sell to both consumers, I'm going to set the price of computer to be $1,500. Price of software to be $200. So now the total revenue in such cases would be 1,500 times 2 plus 200 times 2. So which is 3,400. That's total revenue. All right. Now what I'm going to do is let me bundle computer and software together. So if I bundle together, consumer 1 are willing to pay $2,200. Consumer 2 are willing to pay $1,800. And I'm going to set the bundle, the price of the bundle to be $1,800. And I can still sell to both consumer 1 and consumer 2. So total revenue in this case will be 1,800 times 2. So it's 3,600. And clearly we can see that this is bigger than 3,400 of total revenue when we do not bundle these two goods. All right, so that's commodity bundling for the complementary products. In its extreme form, we have a tying arrangement exists when a buyer of one product is obligated to also buy a related product from the same supplier. Okay, and sometimes it is illegal. Okay, you are not allowed. The law does not allow you to do so. Why? Because firms with market power in one market can use tying arrangements to extend the monopoly power into other markets. And we have such kind of examples. An example would be like in the 90s, Microsoft company tied the Internet Explorers to its Windows operating systems. And in doing so, actually drive the Netscape, the main competitor at the times, off the market. Okay, other explanations of tying, it could be due to quality control, efficiencies and distributions, evasion of price control. All this can lead to tying arrangement. All right, goods and services can also be related on the production side. For example, products are jointly produced from one set of inputs. So when we use one set of capital and labor intermediate materials, we end up in producing more than one product. And actually, you cannot separate them. For example, soybean meal and soybean oil, beef and leather. It could be two different products compete for resources. Okay. For example, Honda might use steel to produce one model or Accords another. All right, let's look at jointly produced goods. Suppose that your firm slaughters sheep. So your product are meat and wool. Okay, so you slaughter one sheep, you produce two products, meat and wool. Also suppose that the demand for wool is very high, demand for meat is very low. Okay, you're gonna say, okay, you're gonna follow this MR equal to MC for each product for both meat and wool. Okay, but now you run into problems. Okay, how can you work out the marginal cost of producing one extra unit of meat, one extra unit of wool? You can't, right? Because they are produced from slaughtering the same sheep. So since you cannot work out the marginal cost of the products separately, well, then you don't want to make your life difficult. So let's not do this. Instead, you combine the MR for each product into a total MR revenue. So now you're going to have this vertical additions and set that total MR equal to MC. And then set the price separately according to each demand. Okay, let's look at the diagram of this. Okay, so this is a demand for wool. This curve is demand for meat. Okay, let me draw separately. And now I'm going to define Q as the number of. So we need to make sure we define a Q appropriately so that we can sum these two products. So let's define Q in terms of number of sheep. Okay. And that's a demand for wools. That's demand for meat. Okay. So now what we want, and there's a marginal cost. Okay, this is common. Okay, you slaughter one more sheep. What's extra cost associated with that? So we cannot work out the marginal. Okay, let's work out the. Let me get rid of this MC first. so that I won't make meat wool, so that I won't make diagram too messy. So we can work out from the demand for wools, we can work out the marginal revenue. Okay. And then from the meat, we can work out the marginal revenue as well. And let's add them up. Vertically. Okay. Before this quantity, let's call this Q. Before QO, okay. So for any 1 unit of ships, so we get a marginal revenue this from meat, and marginal revenue of this from wools. So add this on top of that. So I get somewhere here. So I get something like this. Okay, that's where this comes from. And then after QO, so the marginal revenue for meat becomes 0 and get into negative. And let's suppose that we can freely dispose this. Okay, so now the marginal revenue after QO follows this. So that's the total marginal revenue. And we have total marginal cost. Okay, total marginal cost. Then we follow MR equal to MC here. And that means get slaughter this many sheep, get a price, go from quantity up to the demand for meat. So like we read out the meat price, go from quantity up to the demand for wools, read out the wool price. Okay, that's pricing for jointly produced product.